my regulars who like to talk about modules. Hey, yeah, here, Coffee Compiler Club here today, somewhere about between on time and 2 days late. Um, I'm going to open with modules, but everyone here knows they're being recorded, and you show up on YouTube in an hour or two. And otherwise, I don't typically have a set agenda, and the conversation goes where it goes. Okay, that said, I will attempt to do modules in the doc, although I have it in Markdown format in my editor. But let's see if the docs are acceptable.
Yeah, Cliff, are you able to right click and say paste as Markdown? Paste from Markdown?
Paste without formatting, formatting options.
Okay, go to help and search for the word Markdown.
Sure. Search the menus.
Yes.
Uh, Markdown. Yes. Download is Markdown.
Paste as Markdown is not an option there.
That would suck. Would be a sensible thing.
Interesting. I do see a paste as Markdown option.
You do. We'll cut the shit to bottom here and then repaste as Markdown.
Okay.
Oh, here's a module angry person. Actually, Cameron, I've never seen you angry, so I guess it's not fair. I'm going to go down. We're going to see if Aaron can
Okay.
make this markdown appear
So
as
if I
markdowny.
cut this whole thing
Yeah,
and then I paste it as Markdown.
that looks like it did it.
Hmm. Yeah.
Okay, fine. Well, let's just go through here and then, abuse me as we go because I don't get things right on the first try. So
Fascinating that in the exact same doc, different people do or do not have paste as Markdown.
I don't, yeah, but maybe the search didn't search the right thing. Did you find it from searching there? Like, how did you find paste as markdown?
The other one that's super weird that's like that is inserting a code block.
Oh.
Can only be done by people who have a professional account linked to their personal account. And
Oh.
it's like, why is insert code block a premium feature? That's dumb.
All right. I'm not here to discuss Google's business model. That make no sense to me either. Uh okay, so I have a bunch of goals I listed here. They're not all sensible. It's just what I went through my head first cut. Um, Here is a bad markdown version of the first goal. I really badly want this. Like it dropped the triple quotes, and it's not going to take them here either. Why? Will it do single quotes? No. Okay. Well, file contents don't look filey. Yeah, the goal here was to say somebody can write a one-liner, uh, sys.out.print, and it would just run. And again, missing all the markdown things here. This was supposed to be in it as code.
Okay, at the risk of distraction, can we try one more thing? Go to help and
Yeah,
search for
yeah, do
settings.
it. We're just starting here.
Search for preferences in the help.
Da-da-da-da-da-da.
Okay, let's look at
Yep.
your preferences. Click the box that says Markdown.
Wait. Okay, now you have to cut and repaste, or I do. I might be able to have paste as markdown. Let me
Now
see
you
if I
should be
hit.
able to right click and say paste from Markdown. And you can.
Okay,
So if
fine.
you have Markdown on the
Okay,
clipboard,
so let me
you can
wipe
paste as
this out
Markdown.
and come back in with paste as markdown. This is not very fast here, Google. What are you doing?
You're
Wiped
expecting
out.
a UI built in JavaScript to be fast?
Oh, Cameron, you're super quiet again. I don't understand why.
See, this is a group of people that knows how to computer.
Hmm.
Unavailable.
It's very nice of you, Aaron, to help Grandpa here.
Convert. Well, there you go. I'm going to paste it again without markdown.
Paste
And
from
somebody
Markdown.
else. Oh, come on. What the hell? Just paste?
Just hit OK.
Okay, yeah, I can't do right click. So somebody else cut and paste this markdown. It didn't let me do it.
Hmm.
But I don't know. Or we leave it. We'll just carry on. That was weird. Yeah, so the goal here was to like cut and paste it further down, and we'll switch to the markdown version if it comes through. The goal here is to say newbies can just write a line of code, call simple on hello simple, and have it just run. And that'll just compile it in memory and exec the file and have no files made. It just produces output, just executes. Whoops. Oh, why did you do that? Okay. Then the next one here is I still want to have separate compilation, and that means you have a place to .o files go. So you have to name where your .o files are going to go on the compile line. And then the build directory where your .os go will match any file directory structure that the module's listed in. And here, since my compile line down here doesn't mention another module, the one file pet is the module, and the build directory is where things are going to go. And I have a module, which is a file. So I've helpfully used clinit, which whatever, it's the Java term, but it means a class initializer. C++ is the same thing. So there's some default leggies here, which is basically a static field. Then there is a class description, which has some other fields like name. And I threw another static field down, just to give an idea here. So there is a class initializer, and there is an instance which may have an initializer as well. And if you compile it, you're going to get a pet.o floating around. So that's just separate compilation can happen. And there's a seal init, and then there's an instance init. So let's look at nested namespaces here. Here I've got a repo with pet in it, and some other repo with owner in it. And my pet's much the same, except I added a vet alongside the pet, all inside this one file. This looks really good in Markdown on my Markdown editor. Like, Google, why can't you do this? And so you get a nested vet inside pet. Why? Because when you compile pet, since you didn't specify otherwise, pet becomes the module. And then because pet's the module, vet is nested inside the module. So I compile this guy into some build directory. He gets a pet.o. It'll have the pet.o here. He'll have vet as well as pet in the .o file, in the same .o file. Some other repo here comes along, refers to pet, refers to a vet, prints out I took dog to vet. I scroll down a little bit here. Someone's doing a temp formatting test. Okay. When I compile owner, I have to tell you where to find pets. That's similar to a class path or link line, according to what or pound include if you're C++ or whatever. And the link line here, the lib line tells me, go find, oops, there's double editing going on. Go find the build directory, which will have pet in it. That will satisfy pet and pet.vet. It doesn't have the pet source given there because that would have the same compile dealing with two different modules. And that's sort of not the goal. So go back up here and look at this. Let me look at the file structure here. So there's a pet. I name him as the head of the repo, the module, sorry. And then there'll be a build, can be anywhere, but it can be in the same place. That's what IntelliJ puts it. There's an other as well, somewhere else in the universe. And the owner doesn't include pet. Just the fact you have pet here means it's not defined in owner, so he's going to go look on the link line, find a library with a pet in it. And if he does it, you'll get an error at that time. When you compile owner, he'll say, I can't find pet. Same as you would in Java if you don't have a class path naming things. Okay, so the same example, except I'm going to put vet in a nested file. So I have pet on one file. A directory pet means that everything in here is in the same module as the pet module, but it's pet.vet again, and the build will match the layout, and the other repo is unchanged. That's the whole point of separate compilation. So the pet file here doesn't have vet in it anymore. And here is vet in pet.vet. And, you can go compile owner unchanged, and he looks up in the build repo and finds pet.o, and then he finds pet/vet.o and links and goes. And that's about as far as I got. Here's lazy initializers as an example. Anyhow, coming back up here, sort of, what am I missing? Like this, what I have here is well along, except I'm going to run out of time and go to work. Um, Sort of big ticket items. There's a valid one-liner in my head that's important. Separately, I want to not have to say import or includes because those are just like IntelliJ will just put them in for you. Like they're completely derivable from the local class path, which you have to compile the thing anyhow. So why are you having them in the source code? Um,
I mean, it's one or the other. I think there's an argument for using includes to avoid having class paths or class paths to avoid having includes.
no, when you put an include, you typically don't give a full class path to the final place. You typically give a relative path to some starting point, and the starting point is on the command line. Once you
Right, but
have
you
a
could certainly
starting,
imagine a language where the includes are all relative paths so that when I start a build, I point at one file that is the main, and all other imports are relative
so
paths, and
within a
now you found
module,
everything.
like I don't need to do that within a module because I've already told you where the root of the module is, and I'll just do the hunt. Whereas in a cross module, so separate compilation border boundaries, you always on the compile line have to say also search over there for more files, for more relative path files.
So I will say that that'll work well as long as you have very strict naming requirements between files and modules.
Yeah, they have to be named the same as what I can fit as a identifier in the language and as a file system name.
Right. Yeah, it'll work fine. The challenge is if you don't have that strictness, then you have to check all the modules in that repository. And if Maven is anything to go by, 643 trillion modules is not reasonable to iterate through.
Um, okay, I'm going to start by saying that the names should be relatively should this this is not a automatically suck it down from Maven's solution.
What I'm
This is
saying is that when
a
you have a repository today, you're doing the same thing that developers do when they test enterprise applications, which is they have one stock item, they have one vendor, and their purchase orders always have one line, or their shopping carts always have one line, and they just go through and type one, enter, one, enter, submit, right? And so your database is super fast because you have one thing in the database, total of 3 rows in the database, like big fucking deal, right? Um, if anyone actually uses this, they'll have more than one module. They may have more than two modules. They may have more than 200 modules.
right. Well, I'm targeting a size as what I see in large Java enterprise apps searching the class path. So the search will touch every jar file on the class path and use a hash table per jar file. So for every file on the class path as a jar, I'll do a hash table lookup.
Yeah, so
And that'll be
the
actually
thing that I
one.
have found in C++ programs occasionally is I have this moment where I run across a symbol inside of a file and think to myself, great, I would like to go look at the definition of this symbol. Where is it?
Oh,
So for the computer to look up that path is not so bad. But one of the advantages of having something where a symbol only exists in the file if there was an import that created that symbol, then I know where the symbol came from.
so somebody did a paste that was reasonable. Um, uh, oh, you lost my list there.
Oh yeah, sorry, but yes, so I ended up putting it through Pandoc, converting it to a Word document with Pandoc, and then pasting from that.
See if you can get
So,
the list, the indented
oh,
list back. The rest of
oh,
it
the
looks much better.
list. Oh, the list. Oh, I'm sorry. I didn't.
No, no,
Okay.
no, no, no need to apologize. I guess this is a big improvement. So, okay, so that sounds to me like a tooling issue, Aaron. I hear you. So, like every idea on the planet, you would just go to pet and say, go to definition. It would just like, "Meep."
Yeah, as long as I can control click it and jump to definition.
Right. Okay. So I'm going to claim that the IDE should handle that one. Hey, there you go. That should be doable from an IDE point of view. And then Cameron's question was, how slow is the lookup? I claim it shouldn't be any slower than Java or C++ looking for a name. No, Java looking for a name in a class path. C++ just has to eat the million miles of pound includes, and that's part of why it's slow. And I don't want to do that. I want to look up in the pre-baked things.
Yeah, my point was if you do enforce a naming convention, that then my concern is non-existent.
Okay, I am forcing some naming convention here.
Yeah, that's good.
Okay, and the theory is that the names have to be not a goal, but an implication is names have to be both file names, file system names, and language spec names.
Yeah, I mean the design you have here is pretty close to what we did in Ecstasy, with the main difference being that our compilation unit is a module, not a file.
Yeah, I didn't want to have to do the entire module at a shot.
Yeah, I know that's one of your requirements, so I'm thumbs up. That's good.
Yeah, okay.
No, I mean your design should reflect your requirements.
Yeah, yes, that was just fast compiles because in theory, I don't, what I'm not mentioning here as a goal, it actually is that I'll, within the module under compilation, I will look at timestamps between source and .o files and rebuild lazily. So it will do everyone who is out of date that got touched by the .o in question.
Yeah, so that's the next
Are
job.
you accomplishing that by storing timestamps in the .o files themselves?
Yeah, and of course you can cheat on those, but it's your own directory doing your own build. So if you want to cheat on yourself, you can hurt yourself. So it's Cameron, you were saying something and then I couldn't hear.
Um, I think it was just an endorsement. Thumbs up.
Okay.
But if you throw in timestamps into your files, those will make it non-deterministic builds, right?
If I throw in timestamps, it does what?
If the timestamp is inside the file, then the build would be non-deterministic.
Well, you have a timestamp in the inode for the file itself. Is that what
Right.
you meant, Cliff?
Yeah. So there is a theory that says I can just look on the inodes. I just look on the timestamp from the file system's point of view. What goes in the file will probably have not a necessarily timestamp, but a hash, just as a secondary thing that said, I got the correct version.
Right. So if my .o says, here's the hash of my source, then I can always go check. Has the source changed?
Yeah, right. I'll do a file system check and probably not a hash code check every time, but maybe there's something that says I want to, the bugs here are self-inflicted because you can always do clean and rebuild. And you had to have done something to screw with file timestamps. So you have hurt your own build of your own module.
Yeah, the only thing
if
to
you
keep
mess
an eye
here.
open for,
So-
Cliff, is that the hash may still be required because while you can detect new source files and modified source files, there's no detection of deleted source files. So that's the one thing that's tripped me up in the past with respect to
Oh,
the,
that's interesting.
Yep.
No,
So
I can
your hash is still
I can
useful.
certainly, when looking in a .o, he'll mention the source where he came from by default. That's just going to be part of it, which I can check for the existence of the file and the timestamp on the file, the source file. That should
Yeah.
find missing files.
I'm just a big fan of throw the SHA-256 of the source in the .o because
and then
they're
just
not big and they are
stop.
occasionally useful.
Well, why on earth would you use SHA-256? You could
To
use
slow it down.
Blake 2B,
No,
which is more secure and about
but wait,
2 to 3 times faster to calculate.
slow down. I don't need security here at all. I need speed. And I
Yeah.
need some reasonable catching of somebody's shooting their own foot.
Blake is still faster.
So
So
use
it's
it.
going to be
Cliff,
whatever.
use
If I do
rapid
anything there at all, it will be what is the fastest least effort, which could be fucking Zor 64 bytes at a
No.
shot. I mean, it can be.
And yet better, we will leave it for the
Right.
configuration.
It's
the
definitely
time
not a
configuration.
security question because that's your own security. I'm trying very hard to lock myself out. No, you're not. Okay, fine. All right, separate compilation. What did I do? Namespaces. Oh, I went down here to do. Oh, I was just going to talk about class initializers are lazy. That was the Java learning lesson there. Uh, but that one's kind of obvious too. There's a parent, some children. The parent says I'm in the parent, and then prints the child. Child A has a print. Child B has a print. But when I run the thing, he never does A, child A, because it didn't talk about child A. So you can have classes that don't get initialized and run. So that's fine. I had another thing to ask people here that I
I don't
thought,
see anything here that smells like a header file.
yeah, I'm like, there's no header files, which Java gets away from it except for the imports, whereas C++ has separate header files. And I wanted to not have either one. You're going to put the imports header, the cooked header file, if you will, as types in the .o file. And I have that going right now. So when I compile to a .o, I will dump out, actually currently dumping out the entire IR. It compresses nicely, so it's not much bigger than the executable x86 executable code. If I just had the import necessary bits, it would be pretty small.
So what happens if I have 3 layers? If I have a module that's got a bunch of modules in it that make it up?
I don't. Modules, call it what you want, project, whatever. Modules do not have modules within them. There is a top layer, like your file system doesn't have file systems within it. You may make new parallel file systems that use the original one for like temps, whatever, fuck, I don't care. But the module here is I'm the top. I have files within me. I have classes within me, and the classes nest. But I don't have modules within modules. We could have someday modules within modules.
Does
Right
it
now, it's done.
mean that a module is a root of, represents the whole project or not?
A module represents that piece of project of yours that you can compile and own, and you are expecting to pull in somebody else's modules for other parts that
So
you're not trying to build.
it is representable for the whole project. So you have to
Yeah,
have the
the,
whole.
the hello world is the entire project. The
Mm,
first valid one-liner is a module and a class and the entire project, and it's done.
okay.
I said that, and it's actually not quite true. Sys, as the standard library,
Mm,
is a module. And I'm
mm.
expecting to find that one on the module as a default built-in module lookup, although I'll have a flag that says, don't look for sys. Actually, what happens now is if you don't refer to sys, I won't look for sys. So when I compile sys, sys doesn't look for an pre-existing sys, so he can compile sys himself as a straight up normal module.
Okay.
And then the other ones down here, the class initializers, I said execute exactly once. It's very obvious, lazy on touch. I do have this rule right now that no free, loose, either instances or CL inits mid progress when you start doing other things. So a CL init that needs other CL inits will be mid progress when you fires off other CL inits. But the mid progress CL init will not allow an instance of its own kind to happen until it is done for everything the instance uses. So
Because you can refer to it from before it is initialized. Yes.
right, so you can't refer to it before, right. Um, so I'm going to let you, like the CLNet doesn't have to be completed, so you can have golden instances, but the instances constructor can't refer to fields in the CLNet that have not yet been initialized.
Mm.
And that's just to say that you don't get any Java has this weird thing that in your CLNet you can refer to fields that have not yet had their golden instance put in, so they're null for the moment. So it's not undefined behavior, it's well defined, but they're fucking null. And I just want to say, no, I'm not going to have any cycles here. Module A in Java or class A refers to class B, refers to class A. Class B refers to a static in class A, but class A touches B before he writes the static. So B looks at A and finds a null instead of it's a static final constant. He doesn't find it. He finds a null.
Why don't you like the cycles?
And I'm sorry, I don't like that behavior So I want to rule it out. And the easy ruling out is to say if A touches B, B can't touch parts of A that are not yet initialized. And in fact, I'll make B not touch A, and that means A and B can't touch each other, and that means you have to break your cycle some other way. And there's usually an easy way to break a cycle. You just have to be aware that there's a cycle. Go break it.
Yeah, I feel like systems that I've seen that don't allow you to have cyclic imports, you often end up with this pattern of you have some types module that just defines a lot of types, and then you have 5 or 6 different modules that all pass around the types that are defined in the types module.
Right. There's some header thing you have to do. I can be a little more relaxed than that, but I definitely want to avoid the you got to look at some uninitialized CL init field. And the easier thing I can do is simply say, you've done some partial init, then you touch class B. B can use the partial init, and I know where in A that you touched B, so I know what portions of B can use what portions of A. And if B tries to do something that's afterwards, he gets an illegal compile. A is not initialized yet.
There is an alternative to consider. I'm not suggesting it. I'm saying it's, because part of this project is the fact that it's called simple, so you probably want to keep it simple for sake of argument.
Throw it out there.
But if instead of thinking of CL init as a method that the compiler glues together for you on the class itself, you can actually think of each field as being a lazily initialized. So each field on the class can be lazily initialized. So now if you have A that uses B that uses something else from A that uses something else from B, you're fine. But if you have circularity where A dot X uses B dot Y uses A dot X, then you're fucked. And you throw a circular initialization error.
That's what I'm intending.
Oh.
So maybe I can write an example here.
I misunderstood then.
We'll just use
Because I'm
class.
talking at the field level, not at the
Yes, it would be at the field level.
Okay, cool. That's what we did for what it's worth.
Right.
But we still pretty aggressively shove stuff into CL init, so when we can.
You're still very quiet. If I type, I can't hear you.
You got a loud keyboard.
It is. It's true. I need to get a new one. That would help.
So wait, if you have a class, then wait, what? How does that work?
Not sure whom you're asking.
Yeah, like this is a circular thing.
Wait, is this supposed to be inheritance? What's going on here? Like, how do
No,
I?
this is not inheritance. This is nested classes.
Wait, what's b.field2 mean?
Okay, so let me. This is a circular example. So
Well, I'm just trying to understand the syntax even in a non-circular example because I've never seen that before.
Never seen which before?
That syntax where you're referring to another class dot something. Are those static members of B?
Yeah, these are all static members. So in actually, it's a good point here. In simple, what I'm really doing here, oh, come on, don't do this to me. 1, 2, 3, no, it's going to do it. File a.simple just has, so this is a static. I'm not using the word static. I'll put static in here to help, but that's not the thing here. And then I have file B.
It looks like those were member variables to me, so it's a little confused.
I got you. That's why I'm changing the syntax for this notion. Okay, so here's an obvious cycle. Does that make more sense?
Yeah.
But suppose I want to have A do some initialization and then get a hold of B. And then B does something and gives it back to A. And then let's see here. I don't really want to interleave, though. I'm not going to allow an interleaving going on here. So I'll claim that there is a theory that I can hop back and forth between A and B and A and B, but I gonna say no. So A here picks up field 1, then he touches B, so he has to do all of B. B says, I'm going to refer to a.field1. That's okay. That got initialized. Then I'm going to refer to a.field2. That's not okay. So this is a circular error. So I'll reject this program. Otherwise, if you didn't have that line, then B could use those pieces of A that have been initialized already. And that's because I want seal inits or expecting seal inits to all execute exactly once, execute in some order. There will be a tree-like or a DAG-like, I guess a DAG-like nesting with sharing being first person in wins.
So
It's well-defined, no cycles.
So you're going to validate that at compile time?
Yeah, fairly easily, actually. The initializer for A says, at the time I touch B, the description of struct A or class A is he has field 1 and no other fields.
C++ has something similar, but it's a huge pain. So what I usually do is I just create a function that has a static field, because what that does is and then I return a reference to that static variable.
Yeah.
Because what that does is it initializes it on first use instead of the init rules that C++ has, which are terrible.
That's
This
what I
is
was talking
initialized
about.
on first use.
It looks like you're doing global initialization though. Like you're not initializing on first use, you're initializing on program start. That's what it looks like to me.
No, I'm initializing on first use. So the program here would start with A. So on program start, we're going to touch A anyhow because I'm in theory I'm running program A. So program A has some static field, and then it wants to say something like sys io.print.
Right, but if this happens at compile time, then
No, it's not. No. I compile for A into an A.0, compile for B to B.0. When I run A, he'll start by initializing the A static fields. So field 1 will be 99. That will already be done by the compiler. It's an optimization. Then he comes to field 2, and he'll put aside the rest of A's initialization and go initialize file B. He runs the seal init for file B.
So is the graph tracked at compile time, or is the graph created at runtime? Because there's disadvantages to both approaches.
It will be created at runtime, so I can make an example where that's more obvious.
Yeah, so you could have a function then and that function could conditionally go down one path or another path, and then it could have different module dependencies, and that'll be tracked at runtime.
So here is a random number generator, which says he'll either pick one of B or C to initialize next, and the other one may not ever get initialized.
Okay, that could generate quite a bit of overhead during the initialization, though. So that's what I was getting at. Well,
This random is not at compile time. This is a runtime random during the init for A. Since it's a one-off, one-only time run, it's going to be done in nanoseconds. So there's no runtime overhead here.
Oh, I mean the like building the graph.
The graph is not. It's the only thing you need in the graph is a table for one entry for A, B, and C that says I'm initialized or not. And I guess there's the mid initializer to catch things. And so the start for A says I go from not initialized to mid initialization. He does field 1. He calls the ran. He touches B. So at the B.field2, I'm going to have a check for B to initialize or C. So I'll check the table there. That's going to be an inserted test. That's one of these, one clock cycle test things. And then, I'm off to B or C to initialize it. Then C says I'm mid init. I'm done. I roll back. I'm done with field 2 for A. I print. I'm out.
So this is the same as the C++ runtime initialization, except for the fact that you have a mid state that you're tracking and then creating an error if you encounter it.
Yeah, I'm thinking about if I've gone back and forth that I can check the error and say at compile time and not need the mid state or not. But there is a test here.
You can't if you allow for a Turing complete initialization. It's the halting problem.
Okay,
essentially.
I can believe that. Like I said, I went back and forth, but maybe that's the answer. So there'll be a mid state here.
Yeah, that was going to be my question. Is there anything to stop you from doing arbitrarily slow things during initialization?
Well, you can in C++ and Java as well. Did I ever tell you about how I, got to get hate on Doug Lee for doing exactly that? He made a
So if I want to
CLNet
have,
that had effectively the entire work of doing something enormous, Mandelbrot, whatever, and then turned it into a static value to put in a static field. And I was, had all this great code and optimizations running on for everybody, but not from inside the CLNet, which had all these other initializer issues. And I ended up putting an entire, I don't know what you want to call it, infrastructure in place to say that this function is being run inside a CLNet. Therefore, it has to only be run by the thread that started the CLNet, and I had to thread check you against somebody else who was using that thread to go compute something, using some other thread to compute something, the same function, whatever. I ended up with this weird, you're the same thread, and I'm no threading in simple right now, but you're the same thread as the seal init guy, so you can run it, and somebody else who got it hot and wanted to, compile the code, whatever. Anyhow, this is a giant mess. I'm still trying to think of where I would need. Why do I need the mid case? I hear you, Ryan. I believe you. I'm trying to come up with the test case where I actually need the mid. Like here, I can say B and C, other than B's circular area, it grounds
Right.
me.
So is anytime you have a function that might previously refer to a value that's complex enough that the flow is like nonlinear and you end up solving the halting problem to figure out if
Yeah,
it's self-referencing, right?
I shouldn't be solving the halting problem here. I should be only doing a DAG, and I'm just doing a check. I have
Well,
completed.
that's where
Yeah,
I'm
isn't
talking
this just variable initialization checks?
like branching control flow, like where you initialize equal to the result of a function call, but the function call has an if statement that could in one branch
Oh,
refer to a previous variable
okay,
that
so so
may or
so
not have been
let's.
completed based on what other functions are
So I'm
reached.
in the current example code I'm writing. I only have a random which is running outside. I don't have a function call. So if I put a function call in here, and he's going to do something, he has to get passed in with arguments. So he says rand, b dot field two colon c dot field two, and this function here, I'll put the rand here. You're going to pass me the argument. I don't care what it is, I have to call it, but I could call it any other place in the world, and it's being invoked. I'm trying to come up with the example here that you need here. You need to have the test. This is a function being called from the CLNet, so he has to have the test here. And if B is already initialized, he just grabs the field. So that's the field check that Ben, yes. It's one for the whole class. And I had some other rule about this that only made it work for CLNets had to do this, and everybody else did not. And it was mostly I couldn't invoke field three. That's it. Cannot invoke field three from the CLNet until I am done with the CLNet. That was my rule. So it is illegal to say whatever. Sorry, field four here. Because this requires a CLNet completed. Because field three does not have runtime checks. Because my goal is to not have runtime checks there.
So what I don't know, this is kind of only tangentially related.
Uh,
But one thing that you maybe want to do is like have, if you want to have compile time, um, you could create all this stuff at compile time, and then you could detect it and get all of the like performance aside from I guess random, but like
well, random is read from a network, read a keystroke from standard in, read a config file that got modified just a second ago. right? It's read some external state. You don't know what it is going to return you. So you can't do it at compile time.
I'm
And
personally not a big fan of having global variables that are dependent on runtime properties if they're like constants, because like this is kind of like global constants in a way almost.
they are, and Java uses them all the time, and they're very convenient for Java's
Yeah.
typical use cases. People do this all the
So
time.
the example I think of for that is a lot of the services I work with have an instance ID for every time the service booted up. So they call the Snowflake service and say, give me a unique number that you haven't given anyone else for the instance ID. And we one time ran into a funny circular dependency where under the normal initialization, it would set up DNS and then it would call out and get an instance ID and then it would go do happy stuff. But if it failed to configure the DNS correctly, it would try to print log messages, and the log messages wanted to include the instance ID, but it didn't have the instance ID yet because it hadn't called the Snowflake service because it hadn't set up DNS. So there wasn't a cyclic dependency on the happy path, but there was a cyclic dependency on trying to print the error of what went wrong. And we would get these crashes that were like crashed while trying to crash, while trying to crash, while trying to crash, while trying to crash. And you're like, but what happened?
Yes. Yes. I got those from Hotspot many a time. Oh, we're crashing. So let's gather up some information to go print about what we crashed, why we crashed. Oh, the gathering
But
crash.
that's the only story I have of cyclic initialization really biting me was when
Yeah,
things went badly during the initialization, and then you tried to use the result of the other half of the cyclic initialization to do the error reporting from your initialization.
I have totally been bitten there. Yep.
And we ended up just like removing the instance ID from that error message. And
There's substantially
then
more work in the JVM on circular initialization problems than there is, total on the first 3 or 4 versions of Java.
Oh, yeah, yeah. There's a lot of rat holes there. And I was trying to close them somewhat gracefully, demanding a DAG with a flag at
They
seal
just
init
closed one in like
execution.
JDK 23 or 24. I can't
Oh,
remember the
new
details.
since because there was a butt ton of went in around JDK 5 and between 5 and 8 had a lot of these things come in. You're saying there's another set.
Oh, I mean, they're still working on them. Yeah.
Geez. Yeah, okay.
also some of the cyclic initialization things re-reared their head when they added the new stuff for non-nullable types.
Yeah.
Because
Yeah.
if you are initializing two things that are cyclically dependent, but both are non-nullable, you need to ensure that by the time anything external can see them, that they're not null.
Yes. And I've stared at that case here for simple and decided at the moment I'm not doing it. I got it
Does simple
sorted
have a
for
non-nullable
AA.
type?
I'm sorry?
Does simple have non-nullable types, or is
Oh,
everything
absolutely.
nullable?
Absolutely. if here, come down here. No, 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 no. This guy right here, stir name for the pet. It doesn't have a question mark, therefore it's not nullable. Therefore, you must initialize it. So if I come down here to where I make my pet name equals Fido, if I just say pet foo equals make me a new pet, with nothing in it, that's an error.
What if I just say pet foo semicolon?
Yeah, okay. So yes, I think I can, in fact. This will be an error, cannot be null. Name cannot be null. You must initialize name. So that's the default for things that are pointer-like, unless you put a question mark on them. So come up here in the struct name. You can do this anywhere you have a reference type, and that will allow it to be null. And then it gets a default initialization of null. And if you don't allow it to be null, you don't have a default initializer, you must initialize it, which you can put, the equals, just like I did on the leggies, you could put an equals sign and something. And hand in hand with that, this is a final value as well. So unless you make it mutable, this is a very, I think I either disallow or tell you bad things about it. This is a non-mutable value with a default null. Because it's not mutable, you can't change it to something other than null. That's not very useful. So I think I disallow that one particularly. So this better be, or I change the mutability. So it's normally mutable. If it's going to be not null, I mean, it's going to be nullable. You're going to have it both ways. So you're going to have it be mutable. But with no annotations, that is immutable, not null, must be initialized.
Wait, so structs are immutable by default, like the fields?
In the references, they are. In the ints and floats, I believe I changed the default to be mutable. I'll have to go look. And I'm willing to go back and forth on that one. If you want it mutable, you put a bang on it. Or you use a val versus a var. You can also do, oh, look at the inner doesn't preserve the formatting here. You can do value, which is immutable by default. And I'll take the thing from I'll look at the expression. Why are you doing this to me?
I think Rust uses let, right? I feel like val and var are easy to confuse. I like the idea of using var and let, maybe like let for the immutable stuff, because then it's
Yeah, I
easy
went
to
back
tell
and
the difference
forth.
between
I
var.
didn't mind val. I could do let. It's sort of like there's a one-liner somewhere where I change it from let to val.
Yeah,
Val
val and
fill.
var are more visually pleasing, but let and var are more visually distinct.
Yeah,
So
and right now, is it more important to be visually pleasing or visually distinct? I'm back and forth on it. I mean, honestly, distinct really helps me when I'm reading somebody else's miles and miles of code. And there's an elegance that I pick up from, from Simon that says, "Oh, they should be more the same." He'd probably say, "No, they should be distinct visually." I don't know. They're three letters, so it doesn't matter. I don't know.
Yeah, I feel like I like the let and var the best. I mean, there's also like let. I think Rust actually uses let mute or something.
Yeah, I don't want the two-word keyword thing, so I don't want let mute.
Yeah,
So
you can also say
this is the ways that you specify things in an instance, and immutable is the normal for me for references. And I believe I said primitives like int and float are going to be mutable by default.
and then I think you could also just say const immutable equals 99 like JavaScript.
Yeah, right. Like this. Whoops. Like this. Yeah.
Const e.
Yeah, I could go there too, except that's longer typing. So I would go for let, but const is actually in my head more like as soon as I see let, I'm thinking you're doing some sort of Hindley-Milner functional programming thing. And there's no Hindley-Milner functional programming thing going on here. So let kind of misleading, const is longer. Now we're bike
I
shedding
use
on,
val.
keyword names.
Val works.
And you're like, Val, that was my original Val.
Yeah, you'll also make it hard for Asian people to communicate though, because I don't know if you've noticed, but they have especially like some of the Southern Asians, like we have separate L and R sounds, they kind of don't. So that's one of the
All
funny
right.
accent things you'll
No,
pick up on. It's very
now we're
okay.
really bike shedding. Let's walk
So if
away
you
from
scroll
this.
down to my pet foo
Yeah, let's go follow that
initialization
pet thing
block,
here.
I'm just
or
saying
maybe up.
let is more inclusive because it's easier for
I heard
people.
you,
Um,
but we're bike shedding.
so
Let's walk away and get a more interesting.
foo can never be null. Is this valid code, even though I have my pet foo semicolon?
Um, no, because you can't. You have it in between here, right here.
But that
I
doesn't
don't
matter.
think
No one's
this.
accessed it.
Yeah, I know, but I'm
You
not
said
doing
initialization
a.
runs on first touch, and first
No.
touch is later because I covered both paths. It's not possible for anyone to see the null.
So I hear you. The current way I'm writing that spec is to say no, because I don't want to have a point in the parser where I deal with it as an uninitialized value. There are no uninitialized values held temporarily uninitialized in this kind of context. There turns out there are a handful of places that are, but not
But
here.
you have
Here, I'm just
forward
saying make it
references as a
trinary,
concept in
walk
your
away.
compiler.
Say again?
When I just say pet foo like that, foo is just a forward reference.
Oh no, you've declared a variable right now. Like what you say here is no one's touching it, so
Like
it's
the only
okay.
reason I'm putting pet foo there is because I want it to be available once the scope ends. Yeah, I agree. If you try to print it right there, that's an
No, no,
error
right.
because
But
it's not initialized.
this requires me to handle that case. Instead of handling the case of you've declared a not null value and I now need an initializer. So there's one place where I delay on it. That's in the init function where I demand that it's uninitialized now. You will have the rest of the constructor later. No one can use the object that you're declaring until you finish it out with the rest of the constructor later. So here I would say you just do an easy thing. You just say, run in question mark, pet this, colon, pet that, right? Oops, whatever.
And they won't go out of scope as soon as the ternary block ends
Yeah, just use the ternary.
because there's not really a scope there.
Because yes, exactly. There's no yes. So I have an easy answer for your case. Find a different case that doesn't have an easy answer, and then we can have a real conversation.
No, my main case is getting stuff to escape scopes that
Yeah, well, one of the definite goals is to say that there are no escapes out of the scope for a half initialized object. That's definitely, I'll leave the spirit of your question in the place here.
because there's definitely going to be those times where you want to be like, if Windows do this, if Linux do that,
Yeah, that I was sorting out
and have
in
very different
AA.
initializations.
That's still valid though. You can try
To just do it
marrying
in the
Windows
ternary.
sorry?
To just do it in the ternary.
Yeah, you can
And
do it in the ternary too.
the stuff
Or
that
You
doesn't
can
just
exist
throw it
also
is
into a
dead.
say,
So
function.
so here is another thing that I allow that you could argue is interesting, but not necessarily what you expect. In the constructor, you can set final fields multiple times, and it's only the final value that gets taken out. So if I have a class pet and he has a name that's got a final name field, I can say name equals, null, name equals yes, one, name equals John Doe. And over here, I can print name and it does what you'd expect. It's only final when you leave the initializer. Now, the pet that you're making, the self pointer can't escape. No one else can see this field. Since no one else can see the field, it's not actually got any memory identity, and I don't give it any memory identity. There's no memory made yet. I gather up the fields and then I shove them in the memory object later.
That's
So
that's the
that's
design.
just a
That's the exact
convenient
design that
name.
we used.
Okay, Cameron, you said something and you're so quiet.
I said that's the exact design that we used.
Okay. Oh, that I didn't. Some of your stuff I directly copied on purpose. This was not
Perfect.
one I directly copied on purpose. It sounds like I copied it by accident.
Oh, we've talked about it, but yeah, I mean, whatever. I like it.
Good.
Okay.
Seems to make sense to me too.
Well, the idea is as long as no one sees it, it doesn't exist.
Yeah, right. No one sees
It's
it,
the
so
same, it's the same thing you're doing in an optimizing compiler. You're like, well, if they can't tell I did it,
right. Yeah, exactly. Now for Aaron, your other question here is if I'm in a scope and I make a pet not in the initializer, here I'm like, no, this is illegal, didn't initialize. Nah, can't touch. Right?
but
So
the reason that's illegal is because there is no zero argument initializer.
yeah, because name is not a nullable field. Only from
In
the
simple, can
outside.
you write an initializer?
Um, yeah, you could. I'm sorry. When you said, "Can you write one?" You do this, right? Whatever, John.
Right, but if I just want to pick a default that's like, hey, you didn't give it a name, so it's John Doe.
So Cliff, go to help again.
Oh, you have a better answer now.
Go to help.
Yes.
Preferences again. Search the menus for preferences.
Search menus for preferences.
Yep. Click there.
Okay.
Turn off these stupid quotes. The second item. There you go. You're welcome.
Say again?
You're welcome.
Got it? Okay.
Let's see if it works.
Yeah.
Yay!
Ah, yes. So, okay, back to Aaron, your question was, so this is legal.
In simple, if I want anyone who just initializes a foo without a name, that it becomes John Doe and
Yes.
not null.
Yes. Oh, I see. I'm going to make you do a constructor like thing. So, and then you have to pass in what you're going to give, and if you don't give something. So I don't have a default.
So I assume, Cliff, that what you did there with the name equals John, that's a lambda.
No, it's actually slimier.
Oh,
I literally opened the scope, shoved the entire pet fields in scope as a lexical scope. You're now effectively in the constructor for pet. You're in a private, made on the spot constructor for pet that extends the prior constructor.
sounds like an optimization for the lambda that you're doing. Beautiful.
Okay, good.
You got to learn how to sell these things.
You could argue it's as a lambda. That's not how I thought about it. What I did was, what am I doing here is that's super easy and simple in the parser. Oh, I'll just throw a fucking scope in because that parser makes and breaks them all the time. So I'll just throw a scope in. Finish it out, test things, done. Um, and then Aaron was asking for make me an initializer. And so in the pet file, I can have a static thing called make, build, whatever, called pet, probably if I worked at it, made sure the namespaces work. So this
But if I
is
just put a static function in pet named pet that takes no arguments.
yeah, I can't put a static in pet, but I can put a static in the pet.simple file, which is what I'm doing here. So I have to put a namespace. Let's make sure the namespaces don't collide. Pet is a function which takes a string of my name and returns me a new pet object where if my name is null, which I just have to test directly, because I have a my name, I do it. And if I don't have my name, it's John Doe. John Doe.
So that takes a name question mark. I'm sorry, it takes a stir question mark.
Where's the question mark you're thinking of?
The val pet argument.
Val pet. Okay,
It's a nullable string.
This makes a static field.
Right. That has a function in it that takes a nullable string.
Oh yeah, this has to be null. You're right. I'm sorry. There it is. Yep. And that would give you a pet that has a default my name. But you'd have to add the. You have
not
to
going to
call
get mad at
function.
me that the class and the value have the same name.
Yeah, that's a namespace question I'd have to deal with. I don't know. This would be done as pet as a function, right? Or pet is called as a null. And it's called as a function, so you get round braces instead of calling the constructor, which has curlies. So I might be able to tease the namespaces apart and allow that to happen. I can certainly change the name from pet to a builder or a make, and you would say pet.make, like every Java damn builder functionality on the planet.
Yeah, just name it new.
Yeah. New. Yeah. That's not bad, honestly, pet.new. And it would be new in the local space and pet.new if you were somewhere else but needed to start from the pet hierarchy and get down to the names. It would be namespace new.
Yeah, and if you need 47 different constructors for different reasons, great. They're functions. Give them names.
Give them names.
That means something.
Yeah, it means something. Yeah, and whether or not I do functions with function overloading could fix the different function names. Yeah, there you go.
New becomes a convention rather than a language feature.
Yeah. And that's, I kind of went round and round with like, didn't want to demand you write a constructor with the word pet in it in the class for pet because somehow the constructor was already being built and that field excessive. And maybe I'm being, micro syntax optimizing and still silly about it. And looking at this thing here from Ryan's question, I think what I did, Ryan, was exactly what I finally came around to. I had it in my head worked out. It's you can't call a function in the clinit that takes that requires runtime checks from a clinit. You can do runtime checks get inserted, but you don't call function if somebody else is going to call that function and demand no runtime checks after the clinit's done. Like I wrote it here, but you can imagine now the clinit is done and I'm running some code and the code says call function 3 a billion times. Do I want to check b.field a billion times? No, I do not. So my goal was, or design pattern here was no calling out to a function that will have these checks in it. And I've gone back and forth on implementation. There is a version of that says by the time I call field 3 for static 4, I'm either going to declare an error and demand that you run that manually, or I'm going to just initialize both B and C and then call field 3 without the runtime checks. But there will be no billion runtime checks being run. You'll get one ever runtime check on any given path through the clinits. So shouldn't be the halting problem and should ever only test things sort of once per however much code you write, once per program point.
Did we talk about the compile time eval example in the doc yet?
We got a where? Here, this.
I don't know who put in the compile time
That's
eval.
That was me.
Did they want to talk
Yes.
about it?
What did you do?
Yes, so I have this idea for constexpr. So the idea is like you can evaluate an expression at compile time that could produce an object, right?
Yeah.
And it would serialize the object at compile time. So it creates this sort of serialized state of the object. And this is the sort of the evaluated constexpr thing. And then in the program, you can either get this sort of constexpr.new to create a new one that is equal to the same value as the original, or you can call .get, which produces a reference to a constant that's initialized once at the program start or the first time you use it.
Why don't you
And
address of to get the address of it, or just copy?
Is this for a low-level language, Ryan?
Yeah.
yes. So my idea basically is like in C++, right? You can use things like standard string at constexpr, but you can't create a constexpr standard string that is like a global variable or something, because then you would have to like allocate memory at compile time that is then.
You do it all the time. The allocated memory compile time becomes a wad of bits in the .o file that just gets bulk loaded in, and you refer to that
Well, in C++ you can't. So like you can use the string at compile time, but anything that you like if you allocate memory at compile time, you have to deallocate it before the compile time's over. So you can use it internally. Like you could use these structures while you're doing a constexpr evaluation, but they can't be like the final result. So my idea to get around this is the final result's actually just going to be like a serialized representation of the object.
But I'm like, but why not? It seems obvious.
Well, I think the idea is that like how would the destructor work or something? I don't know.
There is no, you're not destructing it. You built a my type.
That is not true, Cliff. The destructor runs at the heat death of the universe, so you're good.
Yeah, right. Okay. Yes, no, right.
It's guaranteed, by the way, Ryan. So you can put that in your doc.
Yeah. The destructor will run just at the death of the universe. I think that's good.
Thank
Okay.
you.
Well,
I'm here all week.
I think that there are other problems with it as well, but like in this case, my idea is basically, okay, I'm going to serialize it. And then what I figured out, and the reason why I have this sort of .new thing instead of just creating a single global that you would then copy if you need to
Right.
modify it, is that if you take a like serialized form and then you have this deserialized function, and LLVM can optimize that very well.
But you just want the wad of bits in
Yeah, I
memory.
was going to say, don't deserialize it. Just have it laid out in the form that the compiler produces the code to support. And so the
Right.
Well,
deserialization is what we call a no-op.
Right.
actually, here's the thing, right? So if the object is like a struct that doesn't allocate memory, that does work. But
Yep.
if I have an object that has some memory,
But you
then
allocated it at compile time.
Yeah.
And you
You can do
deallocated
this.
at the heat death of the universe. You're set. Do
Right.
it.
You're going to
that's
get some fun bugs if the endianness of your compile machine is not the same as the endianness of your runtime machine,
Right.
but
But those fun bugs apply to everything.
Yeah,
So
that's
if you're
true.
compiling it for a certain model, you're already there.
well, I think there are other issues that can arise, like where you expect the memory to be in the same, like if the allocator has special handling for certain things, there are edge cases I can
Okay, so
imagine that.
you've gone from I've made a value or a structured value to I've made a structured value using a particular allocator that may not existed at compile time, but they may not exist at the loaded
Oh,
execution time.
no, what I'm saying is like the class might expect that the internal pointers come from a specific allocator or something like that.
Right. Well, that specific allocator better be in the pre-cooked memory state. You're basically dumping a Java heap to a disk format and then reloading it
Yeah.
C++
Yeah,
heap.
Yeah, you just
also
use the patch.
sometimes
You just use the patch table for the library to fix up the pointers on load, and you're done. They're
And
all just
yeah,
offset
I mean
based.
that's
So
that is a possible solution, but it's very specialized, so it would require a lot more.
I think that's
mm,
your answer though.
there a use case here where these constexpr built objects aren't going to be global?
Yeah, so
Uh,
the idea here is like
are.
if you call .new, so let's say that you need to like take the result of a constexpr and then modify it. So
no,
No,
no, no, don't what? No,
it's a
no,
const.
Ryan. It's
okay,
called a
like
context for a reason.
no, that's not quite what I meant. So like let's say that I have a function that's like I have a table, and then like let's say there are many different versions of this table, and almost all of them are the same except for some part that changes based on what I'm doing. Like maybe it's a rotation matrix or something, and the or maybe a matrix. That's probably not a good idea because I think
Simplify.
all the
Don't justify. Simplify. You
okay.
have
So
an array which has some elements which are stable and some elements which mutate.
well, not the array itself, but like let's say the function is like generate X transformer. And there is something that is like part of the parameters of an X transformer are the same for all X transformers. And then some other parameters are like different depending on the parameters that you give.
Hmm.
So in this case, you use the constexpr to like generate the basic one,
Hmm.
and then you copy that and then modify the fields that are
Right.
different.
So
Except,
Ryan, I invented this concept. It's called cow. It's
yeah, well,
copy on write,
it's
and
not
I'll
exactly copy
license
and
it to
write.
you.
So
But
here's the thing.
It better be copy on write.
With the new expression, like copy is actually slower than doing
this
a
is
new.
No,
this
no,
is
that's an
like
optimization.
it's
Copy on write doesn't
unrelated
mean
to
you
your
copy.
original question. You're taking a structured thing which has internal pointers to other things, the arenas pointing to the objects or whatever, and you're pickling it out to the .o file, and then you want to load it in and have it be semantically equivalent. And it's actually just memory equivalent. It's just like you took a chunk of memory and you put it out to what the linker does pointer fix up, and when it loads in, it gets fixed up, and you're good to go again.
Well, actually, I didn't do that, but like the
Well, that's
the
what you're describing to me what your
almost,
problem is. And then you're saying
but
serialize and deserialize. No.
because it's a very like if I want the object to use runtime memory, but the structure to be generated at compile time. So I don't want the compiler to like I don't want it to use like memory in the executable file. Like I want it to actually be like a normal object that it produces. Because let's say that I actually like have an initial state and it's complicated to
Right.
calculate the initial state, right?
Yeah.
And so but I need more than one of these initial states. Like every time I create an object of this type, it has to create this initial state, and that state is complicated.
Right.
So for
But
this,
constant. Complicated but constant.
well, it's not constant because like
Well, it's
each
not
instance-
constexpr. This problem just is done at runtime.
well, so here's where I'm getting at, right? So every time I create one of these objects, it has this initial state which was complicated to calculate, but the
I'm
initial state
asking
is
a question.
always the same.
I'm asking a
Well,
question.
the
It
constexpr
just sounds
is
like it
constexpr.
should be constexpr fields in the class, and then when you call new, you
Yeah.
copy the you
Yeah.
refer to the constexpr fields
Yes.
instead of this this way of creating this partially applied constructor from a constexpr function through this deserialization reserialization mechanism.
So the advantage that you get, so with the serializer, it like if I have a constant initial state, right? And then I want to construct a new object that's a copy of that initial state. That is slower than doing a deserialization using a blank
Why?
object. I do it because the deserialization basically the way LLVM can do this is it can basically inline all of the serialization steps. Whereas when you call a copy, that is a more difficult optimization to make.
Why don't you
Not
override
in-
the copy constructor to keep a reference to the const expression as
Yeah.
its baseline, and then just layer on the changes on top of that.
Right.
But you can't do that if the constexpr expression uses global memory, though,
Why
Yeah.
not?
because
Certainly.
the optimizer has trouble like
No.
tracking memory
The
when
optimizer has trouble is not the language semantics has trouble. But I don't see why the operators have trouble. I do this fucking time all the time in Java. This is like I had a golden instance. I just copy it with memcopy, and then I patch it up, and away we go.
right, but that's like the generic copy is a little slower than the specialized copy because like if the object has a
No, don't talk speed there, especially small instances of speed, because very clearly I do memcopy of a golden instance. It's entirely specializable, and of course it certainly is specialized.
well, not all structs are memcopyable. So like some structures have like
Okay, so
pointers
this
and
is a
stuff.
different thing. So you have a constexpr that's not memcopyable. It kind of gets into a different zone. It's not got memory. It's got something other than memory in it, because memory can just be copied. So it has something other than memory in it.
Well, it has memory, but it's like a container that has like a graph of pointers and sub memory allocations, right? So it's like a graph of
Yeah.
memory
So
chunks.
now if you have to do the clone of the graph, because that's you're trying to copy a complicated clone, then you get into somebody has to do a fix up, and they're still probably faster. This is what the linker does. It's going to be bulk copy and then patch pointers.
Right. So the faster kind of way is the deserialization function can actually be faster for some of these based on what
I wouldn't design your language around it can be faster or not. Get the semantics and then figure out how to optimize it good enough. And if this particular special case becomes the most hottest thing on the planet, somebody will work around it and make it go. But typically it won't be. So like don't twist your language semantics around an edge case.
So is the language semantic question, would you rather have constexpr or Compiletime expr?
No, they're both constexpr, but like the idea here is like you can call .new or .get on the constexpr instead of like just so like in C++ a constexpr is going to be like basically an int or a float, but you can't have a constexpr string.
Why can't you have you certainly do.
Well, you can have a string within a constexpr evaluation context, but like it can't be like you can't declare static constexpr stood string equals something. You can't do that in C++
I would
because
assume we could return any value type, no?
I thought it could.
no, you can't
Java
create
does
it.
this shit all the time.
in C++, you can't use standard string as like the result of a static constexpr. You can do it internally, like you can have standard strings while you are calculating something that's
Right.
constexpr, but the final result type has to be like one of the primitive types. Like the final result could be an int or a bool, but the final result cannot be standard string.
It doesn't make any sense in my head, but you could be. I mean, like I said, I do this all the time in Java. Java does all the time. Any clinit, any class can have constants
Do
within
people
the
find they
static
use
constructor.
constexpr for compute heavy things often? I mean, I don't know the C++ constexpr semantics, but most of the time,
they want to crunch a bunch of stuff at
The
compile
AI
time.
compilers are in fact doing this.
okay.
They want
Because most
to.
of the times I've used compile time execution, it was just like compile all the regular expressions or suck a bunch of SQL files in so that I can have a separate .SQL that the language doesn't realize is source code, but is totally source code.
The AI compilers are doing this now. They want constexpr for the layout of various tensors, which varies according to the hardware platform. But then they break out the matrix multiply and the tiling according to the hardware platform, which is complicated. So they have a very large, complicated thing that boils down to a constexpr, which has a bunch of tensors laid out neatly in memory that the GPU can munch without further calculation.
I see.
So
And when it's done, it just gives you 13 different functions. That's like if you're on hardware A, call A. If you're on hardware B, call B.
yeah, yeah.
Well, the idea behind constexpr is the evaluation of the thing happens at compile time. So like if you say constexpr my foo value equals, let's say Fibonacci 1, 2, and you have the dumb Fibonacci implementation that is recursive and it takes a long time, that will happen, but at compile time. So when you run the program, it's just the value, it's just the int, right? But this extension is like how I'm able to represent more complicated objects without doing a patch up, I guess, because as long as the object has a serialized and deserialized function, then it will work.
I don't think you need that. I think that's excessive.
Okay,
So let me restate briefly on the standard string case what you just said, because it's very simple and very concrete. So I'm not going to try and explain you away. I'm going to try and explain where you're coming from so that I kind of understand it. So standard string has a header pointing to an array of cars. The header has like length shit in it or whatever it's got, but there's a memory pointer involved. There's two pieces. So unlike an int or a float, which is a single atomic thing, there are two parts, one of which points to the other. Under that model, C++ says you can't make one of these as a constexpr. I don't know why, that makes no sense to me, but I'll believe you on it. And you can imagine a much more complicated series of things with internal pointers. Having that said, and you have a constexpr version, now I want to take that at compile time, set it into the runtime, and at the runtime, I want to take one and begin modifying it, for which theory says I need to do something like bulk copy, including all the internal pointers, and isn't there a better way? Is that
so
sound right?
I guess like the question is like how would you write the class that can be like patch how would you like write a class that would be able to be fixed up like that? Like what would the syntax be? Because I'm actually like struggling to understand like how you would even write that.
So the
Like
there's
for
two different
string,
pieces here. Java definitely has lazy init on classes where somebody does a complicated initialization, produces a big, complicated, hairy thing, now declares it a static final in the clinit of a new class. It comes late in life. The JIT comes late, sees a complicated static final, totally treats it like a static final at compile time for the JIT, which because of the
right? But
static JIT, it gets away
it's
with
in
it.
C++. This is
Yep.
that like the Java version of that is not the same as constexpr because in Java that's happening like after I launch the program.
Yeah,
Like in
no,
C++,
let's be clear. It's interleaving execution and compile time. Because of the interleaving, something fancy happened at runtime, and then the compiler got to take advantage of it as a giant global
yeah,
constant.
constexpr doesn't make any sense for JIT languages because the whole
Yep.
point of constexpr is that this happens when I am compiling the program, and therefore, if I launch the program, it will not occur. Like all the calculation has already been done by the time you launch the program.
Yeah,
So for
I get it. So I'll agree with you. You want to do something here at constexpr to make a thing which is complicated, has internal pointers. Now your next piece of the thesis I'm hearing is I want to take this complicated thing, which is a constant value, and I want to begin mutating it. I want to make a copy of it and mutate the copy.
Yeah, like make a copy. You're not mutating like the constexpr value, like the constexpr thing that's like the myval that's declared constexpr itself cannot be mutated because it's constexpr. But
Okay.
you can create myval.new, or you can
You want
use
to make a clone of
myval.get.
the complicated structure and then mutate the complicated structure. And that's why you're claiming serialize, deserialize, which, by the way, has no magic secrets to it. Any of the copy and update pointer operations would do the similar thing. Would it be a good way to do it or an efficient way? Or would you just be faster to rebuild the complicated thing? It depends on what you're doing to rebuild it. I can make a case go both ways.
So I think when I think of fix up, what I'm thinking is like you've got the entire structure of the whole class, and then you have some pointer fields that are like not set, right? And then you go back in and patch them. I'm just not seeing a way to like have a user-defined class that can implement that patch up, that fix up thing. Like
No, right.
I don't see how you would do that with like something that's not compiler built in. Like the syntax, I'm
Right.
just like if I declare if that string class is my own string class, right? I would be able to implement constexpr as long as I have serialize and deserialize. But if
But that's a reasonable thing to go with. That is, you just said I don't have any way to do it with a compile without it being a compiler built in. Okay, so you wrote your class that makes a version of myval is just the constructor, the normal constructor in the first place.
so one of the I guess core principles of my language is that there's not very much difference between primitives and user defined classes. Like everything is like consistent. So like if you could do something with a built-in, you should probably be able to do it with the user defined class as well. That's like kind of a core
Well,
principle.
the built-ins almost always have this property of their value like and atomic. And user guys don't have to be value like, especially if they have internal pointers. That's typically not considered value like, and they're generally too big to be atomic. So immediately you have a couple things you do with primitives that you don't do with user types. So you have different things you can get away with on them.
Well, I don't agree because to begin with,
Not going to
like
be
user
atomic on
types
a
are not
multi.
atomic
You're not atomic.
because okay, like on x86 you could get away with this because like load and store of int 32 is atomic on x86. On other architectures, there's a separate instruction for an atomic, like ARM has a separate
There's
instruction for an atomic store of a 32-bit int, and it's slower than a non-atomic store of a 32-bit int. So like
the arms of sufficient size will all be atomic without doing anything different about them. That's a bad example. There are better examples, but the fact is true. So pick a particular size. At some point, different pieces of hardware will say not atomic versus atomic on a 64-bit versus a 32. Like
no,
32 is
like
always
on
atomic.
ARM doesn't have cross-core memory ordering by default. Like okay, so on
Okay, no, that's
x86,
different. No, that's different. I
well
said
that's
atomic.
part of the atomic definition from my
No,
perspective.
no. Well, you can call it what you like it, but that's a different thing. That's an ordering, not atomic.
Okay,
And
so
everybody's got different ordering rules.
there is a ordering, there is a minimum set of ordering that is required to have any atomic operation at all. If I can do a write from two cores and those two write like a read modify write and they're totally unsynchronized to the point where like I have core
This
one,
would be true of an x86 doing an add to memory, as opposed to a locked add to memory.
right, but like some types that lock is not there by default. Well,
I'm
I guess
saying
that's true on x86 as well,
typically
yeah.
you don't lock, therefore it's not atomic. Therefore, two x86 cores who are incrementing a shared counter will
Right.
drop some counts. What will be atomic is 32 or 64 bits being written at a shot. At a later generation, 64 to top. Earlier generation, no.
Yeah, so the atomic is not really like even I guess even on x64 you're right that an int is not atomic by default.
The The early generations, no. Later generations, yes. Depends on
Well,
the
it's different instruction, and it's a
No,
slower
no, no, no.
instruction.
The same load 64 bits on one hardware on x86 was atomic. On another hardware, you would get byte shearing.
What I mean is if I do plus equals, if I'm think a type
But
is
plus
atomic,
equals to memory. Add a 1 to a memory location. Yes.
anyway, I guess that's kind of a tangent because I think that
It is. You're
atomic
trying to break
is
out. What I was said about atomic holds, assuming all your values are carefully aligned, power of 2, blah, blah, blah. If they're small enough size, they're always atomic. If they're large enough size, they're never atomic. Varies in between by generation after that. All the normal primitives these days are all atomic. Didn't used to be. The long 64-bit ints were not atomic on x86s and many things. They are now atomic. Okay, that's no
so.
order.
My I guess one of the philosophy designs I've inherited is that there's the abstract machine, and you you program to the abstract machine and not to your architecture that you're
Yeah,
compiling
right.
for, because that allows more optimizations.
Yeah,
So
yeah.
there are like examples where
I had to implement Java on a whole lot of variations of x86 and ARM and a lot of things. And there were times where, the abstract machine was the Java virtual machine, but the actual hardware was not atomic on 64 bits. So you got byte shearing on 64-bit loads and stores. Okay, that generation's passed. We don't see that in any modern chip. That being
right.
said,
So
the different hardwares have different ordering requirements, and
so
that's
the
different
way
from atomic.
C++ handles this is it says, okay, all primitives are not atomic unless you say they are atomic, and in which case
Yeah.
it will add the extra instructions if they are necessary, and it
Okay.
will not add the instructions if they are unnecessary. But like from a theoretical standpoint, all primitives are not atomic unless you set them to be atomic, and the compiler will also do optimizations that will break your code if you like say, oh, I am using a 32-bit int and that is atomic on x86, but it isn't because the compiler is like, oh, hey, here's an optimization that's legal for a 32-bit int that isn't atomic. And it will do the optimization. And like the assumption that your int was atomic might have been true for x86, but not from C++'s perspective. So the optimizer did something that made the code, it would like,
Okay,
it's
so,
still
so you're,
correct from the perspective of a non-atomic int, but it's not correct if you assume that
you're
the int's
arguing that
atomic.
C++ is broken.
No, I'm saying that's like an intentional design choice because
Yeah,
there
I
are
heard you.
optimizations you can make. Like if you do so, like read, modify the copy, and then write back, read, modify, copy, write back. You keep doing that over and over in a loop. C++ can go, oh, there's an unconditional write at the end of this loop. I can therefore read it once and then, or I could like, and then write it
Yeah,
back at the end or something.
yeah.
There's
And Java
different.
does the same exact thing for the same exact reason. The language semantics said there was no requirement to share across core, so I'll just put it in a register, do my math, and write it out once.
Weren't there in Java, so in the unsafe, like a put ordered int, something like that, which doesn't imply
There are
atomicity?
also unsafe ordering operations in Java that you can call it specifically to
Yeah.
force memory orderings outside of
Yeah,
the normal
one
volatile.
implies memory ordering, the other is a full atomic
Yeah, yeah.
effect.
These are separate from ordering, separate from atomicity.
Yeah.
So we're arguing that C++ has this thing that says if I don't ask for atomicity, the compiler does what it wants, and if I do ask for atomicity, it has more constraints. But on different architectures, how those constraints manifest vary.
I think Java has a little bit of a different memory model because to my understanding, Java guarantees that like operations have at least a relaxed, what C++ would call a relaxed ordering. Whereas in C++, if you do a modification from two different threads concurrently without using atomics, the whole program behavior is undefined. And
Yeah,
that
that's
allows some
the
extra
Java doesn't believe
optimizations.
in undefined behaviors. So you don't
Mm.
get an
Yeah.
undefined behavior. That's not necessarily
You
so.
get
Right.
one or the other. It doesn't
Yeah,
count.
yeah,
Yeah.
yeah.
In C++ though, like if it's not atomic, it's not even the relaxed ordering.
Yeah.
You just get like crashes or whatever.
Right,
Like
right. The
anything
missile
can
gets
happen.
fired, your chip burns. So we all agree we know that C++ has this issue. That's
I
not
wouldn't call it an
exciting.
issue. I would call it a design decision
Uh,
because
okay. I'll call it an
yeah.
issue. You call it a decision. That's fine.
It is a performance enhancement at the expense of safety, and
I would
that's why
claim
it's a
it's
trade-off.
not a performance enhancement, having observed for many, many years what so-called performance enhancements you get out of such things, and you don't get anything
How
significant.
it's a performance
So-
enhancement if
But-
it's not correct?
Yeah, right, exactly.
If your program
It,
is
it
not correct.
because there are ways you can write correct code that does
Yeah, as
those
soon as you go
operations.
away
But
from defined behavior, then you're in the same zone as everyone else is, and it doesn't matter. Like, this is like a silly argument. C++
Okay, so-
has a model that no one else on the planet uses, and I don't think it's a smart model.
Except
and you
C
think
and
it is.
Rust. Except all the languages that are at the top of the performance benchmark. Even Rust has the same memory ordering model as C++. It just locks it behind the unsafe keyword. Like, to get the highest performance, you have to use this stupid, annoying, and hard to use memory model to get the highest performance in multi-threaded programs. And whether that happens, behind an unsafe operation somewhere hidden where
All right,
hopefully
right.
it isn't
We're
exposed.
we're not being very productive here. This is an old argument, and also, I watched like the Java Billion Row Challenge,
Okay,
and like you
I
get
get
fucking
it.
fast code with no undefined behavior. So,
But it's 5% slower or whatever. It's like
No, it's
you
not.
can't.
No.
I'm looking at benchmarks and I don't see Java at the top of them. I see Rust, C++, C, and sometimes Zig.
Yeah. Well, I'm looking at benchmarks that have Java at the top of them, so there you go. And let's not go he said, she said without going to facts.
Okay.
And
So
pick things that make sense for each place. There's certainly
shifting gears.
with Java.
And it's recursive. This happens on every layer of the stack. Google essentially built their entire company on, we're going to put stuff in key value databases that don't have all the ACID properties of databases. And we're going to build our search engine, because the fact of the matter is, the search engine is not right or wrong. You just have better or worse answers.
Yeah.
And they were kind of okay with the crawler stepping on itself and stomping things occasionally because, okay, so you lost 3 pages because something got stomped and those weren't indexed. Oh,
I mean,
you've
what
still
happens?
got a trillion pages.
Like you push a write and it causes eventual consistency.
Gradually over the years, they have taken more and more stuff and moved it from these eventual consistency key value stores into ACID systems like Spanner, because they found out that, well, it is entirely possible to write working software on eventual consistent models. Developers are much more productive in ACID consistent models.
There's certainly lots of situations that we use Spanner, but it's not like everything goes in Spanner.
All right, let's
because you want both models. You want to have your eventual consistency database, and you want to have your consistent database, and you want to use them both intelligently and make those choices intelligently. Like, to say one is good and the other is broken is...
Going back to the constexpr thing, just a quick question. I think you're trying... Well, statement question. I think you're trying to solve the deep copy issue with the constexpr object. So you definitely need some sort of user-defined function to define, just tell the compiler what is and is not in scope of the graph it's going to copy.
Yeah, what's a deep copy? Yeah, that's a good answer.
So that's why you're having this deserialize reserialize issue. You need that deep copy definition.
I would say if it's a const expression, it has to reduce to a value, period. If it doesn't reduce, it's not const expression.
The particular values in question have internal pointers, have memory state with internal pointers within themselves. So they're still const, string and a string body and a string header. The header points to the body, and the header has like length and hash and whatever crap in it. Right?
So they have to be effectively const. They have to be effectively known at compile time. They have to be known at compile time.
Yeah, known at compile time. But when I copy it with a mem copy, if I just take this thing, which has a pointer from here to there, and I copy, the header will point back to the other dude. It won't be an atomically self-consistent copy of the string header here. This is his core problem. He needs a deep copy.
I would argue that it makes sense to me to copy.
Doesn't do the trick.
If you copy the string, it makes sense to me that you point to the new copy, to the new point of the size of the string.
But to do that, you can't use a mem copy. That's what I'm saying. You have to update the internal pointer. You got
Okay.
that's the issue. Now, if the array was invariant and you just did a shallow copy of the header pointing to the invariant array, that's how values work. It's all great. But if you wanted to modify the contents of the string, and I'm using string here as a bad example of anything with internal pointers that I didn't want to mutate. You make a bulk array copy, but now you didn't copy the graph edges that are internal. And now that's what deep copy does.
So, okay. Can it reduce that to a constant, to a value that can it finish that copying and say, okay, I'm a value from now on? If that, then it qualifies for a constant expression. If it cannot find
make the thing, including with internal cycles, and declare it a constant from the compiler's point of view, but I can't bulk copy it without updating internally. That's this funny extra new state. Like Java, I'll certainly make these complicated things with internal loopy whatever pointers. And the next JIT step afterwards will know it's a constant and deal with it as a constant. Okay.
I'm just wondering, like, let's say I have a user-defined matrix class. How would they, like, without serializing and deserializing it, like, how would you make that able to be a constexpr?
You declare it consequence completed. That's unrelated. To make a copy, you need a deep copy operator.
But then that's not constexpr. You're just creating a regular object, right?
I'm created an object that I've declared by fiat. It's now a constant. It has no. I'm not going to let you ever mutate.
Right. Constext and constexpr are different though. Constexpr means not just that it's constant, but that it is a compile time constant. Like
yes, at compile time. That's the same thing at compile time. So if I throw down just anything with the internal state.
To me, that would mean evaluate that until it's reduced to a constant and use that. And
why is he going to have to be italicized here? How do I get rid of my italics here now? No. Oh, fine. I was going to throw a little example down here, Some int array, some x's. Okay, it's just an array full of constants. I declare it constant because I don't have a way to say it in Java, so I'll do it in C++ E here. It's constant both sides.
But const doesn't imply constexpr. Those are like you could have a.
But why not? No, don't give me the C++ definition of constexpr. In a language where I'm expecting to produce a value at compile time, which has memory state, I can still declare it as a compile time constant once I reach this point. Like I'm doing this in simple now.
All right, so here's I guess the thing. Like if I have my, I don't know, like I have an expression, right? So my expression is, let's say my expression is foo, my eval 6 7, right? And I run this, and this is inside a function.
Okay,
and then
what does my eval 6 7 mean?
So that would depend on the implementation of the class. But like the thing here that's useful in C++ is you can say, oh, my val is a constexpr value, therefore I can go ahead and access 6 and 7 and inline the result of that to just be a constant.
Yeah, right. This is exactly what I'm doing here.
Yeah.
So whatever excess of 2 can go inline that as a 2.
Yeah.
And I'm doing that right now with simple and Java both.
Well, this is a compiler optimization. Like it's taking this and then it's requiring the compiler to figure that out.
Right. It will do the same thing, but const expression, at least to me, that const expression is where it came. It has to be expression. It can be expression. Cliff is saying that we'll evaluate that all the same. Just const expression forces to happen at compile time, and it's guaranteed to happen at compile time.
Right.
That's the thing. Both do the same thing.
So I guess my issue here is that a constexpr function is not able to call memmap or sbreak at compile time because those are not
then
here
is the problem. Machine. So they cannot be reduced to a value, so they cannot be const expression evaluated. So the compiler cannot evaluate them.
But see, I disagree. I said new right here.
Okay. Yeah.
I said new. Yeah, and at compile time, I already know that I'm going to allocate some memory. In this particular example, I actually don't need the memory when I'm done. I'm just going to eat the 2 out of it and throw the thing away. But I could, and I will, take that as a constant pool thing. It'll show up in my constant pool in my ELF file. there'll be a 1, 2, 3 sitting in a constant pool somewhere that has been allocated at compile time, but now that allocation's at runtime because I threw it in the constant pool.
Right. So how do you
That's still
teach
fine
the
to me.
compiler to translate your allocations? Like
So-
if it's doing a random syscall, how do you teach the compiler to translate the allocation to a fix-up?
So in this case, I've said I have a value in my type system, which is of type constant sized, constant valued array of constant bits. And then I
Right,
just, when the
right,
elf
right,
writer says, if I see a constant typed thing and therefore it has all recursively subconstants with internal pointers, whatever, all constant bits, he spits it out into the constant pool. That's a constant pool writer step.
One
but
difference with constant expression, at least to me, if it's that around and it cannot figure out at compile time, it will not throw an error.
Yeah, that's not a
because-
constant then. It's not a constexpr.
that is not a constant yet.
so
Right.
so how do you make your like my class, right? Like
Yeah.
you're writing your own class. How do you make this able to be used in constexpr without doing the serialization?
Oh, I just
Like,
said I serialize it out to the elf file.
okay, so
And,
you are
when you load the elf
serializing it.
file, he just slaps that memory up, does the linker patch up thing, does the standard elf file patch up if he has internal pointers.
So how do you write this class syntax such that the compiler will know how to generate the function to do the patch up?
Oh, there's no function to do patch up. That's the linker does the patch. You have a
So
you
how
have
do you
that
teach
compiled.
the linker? How do you teach the linker how to patch up a custom user defined class?
You only are allowed to patch pointers internal to the self structure. That's the linker only understands this limited kinds of patching. He has other patching for doing whatever instruction.
But what would be the syntax? Like if I declare a class.
There's no okay. Yeah, there's no syntax. I wrote the syntax, if you will. Literally, if I
You've
just
done it
come
for a
through
built-in type. You haven't done it for a user-defined type. This is a built-in type. How do you do this for a user-defined type?
every user-defined type is a collection of built-in types, and that's it. I only end up at the basement level is a giant wad of primitive types. So type struct contains every other type on the planet recursively, and that's all I'm going to use to go do things. User-defined type. So somewhere in the world I made a struct has an int x, but maybe it has a
No, put the array example from above and how it
okay.
will
But
play
I'll
out.
also make a pointer in here. So this is a linked list. He has a next field. He has a payload, int array payload, and the payload will be whatever, but I'm going to make a constant. So I make the structures defined like this. Somewhere in the world, I have a val, and it has my linked list is a new linked list, and he says no, but I want a self thing, so I'll make another one in a second here, and a new int 1, 2, 3, like this, something like that. Val linked list number 2 takes a new linked list of a linked list, it has a new int, and let's align them for pretties. And
So this sounds like
6.
at least your new is built in this case.
The new is built in, yeah, same as any other allocation language on the planet. Malloc and C++, new in Java,
It's
everyone's
not built
got
in.
a new.
There's no built-in allocator.
There is a built-in allocator in C++ called malloc.
No,
tell me that
well,
malloc
I
is
mean, I'm talking like constexpr. This is not a built-in. There's not a built-in allocator.
So here I've said new this is all set up in compile time. Then someone comes along here and says, oh, I want to call foo with L2. I will look at LL and L2 and declare them all consts by inspection by the compiler. He'll do this normal type analysis. Before I even leave the parser, he'll tell me that LL is completely a constant thing. Has some memory layout, whatever. Same thing here. Because it depends on other constants, it's a constant as well. This I'll get out of my parser even before I've gone anywhere. Just normal type analysis. So when I want to call foo and say foo's external module, I need to pass the address at L2, the reference to it. I need to throw the damn L2 into the constant pool. So when I come down to IR, somewhere have a new constant node of L2, which has this entire wad of memory state. It gets down to the ELF writer. He says, "What is your type, Mr. Constant Node?" "Oh, you're some complicated memory thing." "Well, I'll have to throw it in the constant pool." And I'll walk the internal structure of this constant object and stomp it out into the constant pool. And when I see pointers inside from one to another, I'll go add a patch reference to the linker patch site. And you'll get that layout out of the constant pool in memory after not the linker, the relocation step that happens when you load an exe file or an ELF file. There's a relocation step. It'll patch it up. All the internal pointers will patch and it'll be done. Then he'll call foo with an address out of the constant pool, and it'll, away you go.
But that would actually reduce to a value. It will chase and it will reduce that to a 5 here. Would that be equal to 5?
So I don't know what foo does, right? So I'm claiming foo is an external module. I don't know where foo is. So because it's external, it's opaque to optimization. I need to hand it this constant thing. So I'm going to say I have the generated code here. So after the constant pool fix up happens and the program launches, the generated code will say, call foo, load RAX or whatever the first RSI, the first argument with the address of a constant pool, call foo.
Yeah. So this, I guess, in C++ doesn't work because there's customizable allocators. So if you create an object of type std string, that's actually std basic string that has the allocator set to the standard default allocator.
This is like unrelated in the sense that I can replace the new here with some other allocators. I made a big array who, in the end, that guy called sbreak or malloc and got a wad of memory from the OS. And somewhere in the world, he's declared I have an arena that has a wad of memory of a megabyte or whatever size arena chunk. And then internally, I filled in the bits. You would get this out of a custom allocator too.
What if that is declared as constant expression?
Yeah, so differently. So right now, under this tiny 4-line program we've talked about, I will say compile error, foo is not a constant.
Yes, that should be the case.
Well, you have to declare foo in this compilation unit.
Yeah.
Now, if you declare foo in the compilation unit as an obvious optimizer thing, I'll just start passing the constants into foo.
This is what it means to me. The compiler cannot evaluate the expression to a constant, and that should be an error.
Yeah, this would be what you wrote would be an error because the compiler can't evaluate.
Cannot evaluate at compile time. That cannot evaluate the expression. So that is what it means to me.
So this is an error. I'm going to comment it out so we understand that this is an error. Why are you doing this to me, you evil bastard? Whatever / you think you do.
The only thing that needs to be constant is the return value. It can do unconstant things in the middle, right?
No, because I have to have foo at compile time.
You have to evaluate.
Under the thesis of this description, we don't have foo. Foo's in a separate module, separate execution unit. I don't have foo.
You have to be evaluate. You have to be able to run the program during compilation. And reduce that.
Yeah, and so the other thing here is I could come through and say, this is legit to put constexpr at, because I can see all the parts and realize I know them all, and therefore it's a constant.
Yes.
And the only reason to put the keyword there is to enforce my understanding that I believe this should fold to a constant.
Yeah, because if in simple example that if it cannot reduce to a constant, it won't say anything. It will resort to a runtime behavior.
Right. If I choose to not fold the constant into the constant pool, you get an allocation of 3-element array and a struct, and he patch all the things in and do all the work at runtime.
That is at least to me the difference, Ryan, between constant expression and what it's doing here. It will optimize it if it can to a value, but if it cannot, it will resort to allocation.
Yeah. If you say constexpr, I claim it should evaluate it to a constant.
The constexpr is a hard guarantee. You either get a value or an error.
Yeah, and this is what the AI.
No, but he's talking about expanding the definition from just being values into objects.
No.
Syntax.
I think that objects can be values if you're not in Java.
I'm declaring these are all values, And Java would treat them as values, but that's not part of the language spec.
And this is not limited to objects only. It has to be an expression. It can be anything that can fall to can collapse to a value. That is why the expression here in the const.
The thing the AI compilers are doing is they're saying, we have foo, I pulled it out of the library, I have it, I can evaluate it. If you say constexpr, I must evaluate it, even if the normal optimizer heuristic would not inline foo here. The must evaluation force would say, okay, inline foo, evaluate it, blah, 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 and get it baked down. And that's what you hand off to the GPU as a pre-baked thing. But he forces the constexpr on a much larger scope than your optimizer would typically optimize for.
But can't it also move execution from runtime to compile time? So like
That's
if part
what's
of my
doing.
constexpr expression is read this file off the file system,
No, you
it's
can't
going to
do
read
that.
it off the build file system,
Yeah,
not the
so
No,
runtime
you
file
can't do
system.
that. You
You
can't
say
do that.
that, and I know XDC is, and I like the notion, and I've totally done that in gaming land. Like, I have a pixel of a stupid little sprite that's going to bounce around, and I have it written as a fucking pixel file. So I wrote shit that said, eat the pixel file and spew out a pile of junky C code that was just the pixel bits blasted into line so that I could have it at compile time.
Yeah, so you can't do that in mine because like basically the way that it works is there's a function constexpr alloc, and you have to switch on a runtime statement and say, okay, runtime constexpr, do constexpr alloc, runtime not constexpr, go call memmap or whatever. And so, but there's like no access like in the constexpr evaluation context, like you don't have assembly, you don't have system calls or anything like that. Like it's in a virtual machine and it's sandboxed.
Well, sprite.
Of course, there's been this extension called Circle where you could use pretty much the entirety of C++ at compile time, including reading from files, doing network connections during the compilation, and then maybe saying what was in a file, what was from the network connection, and then compiling that, baking this into the executable. At compile time.
That should equal the Z comp time, I think.
This is one of these, is there a way to syntactically force it in the language? Oh, maybe constexpr forces it.
Yeah.
It's a nice thing to have for a lot of programming issues.
For functions, you can enforce some things. So you can enforce initialization with const init. That initialization has to happen at compile time, but you can still modify this expression. And you can also enforce that a function has to be evaluated at compile time with const eval. There is some enforcement.
Yeah.
Right.
But the const expression being the combination of the two, yes.
I want a constexpr now, and then I'll put it in a thing that's not final, and then the code. Okay, here we go. So this is like, I want this to be constexpr, and this to be non-final. This is a var.
Yeah, it depends where to put the const modifier. The
and then and here are his. Turn.
Yeah, I like that.
Sprite zoring for flashing, where I'd say sprite of 0,0. Oops. Zor equals -1, and repeat that for where's my Zor? Repeat that for all pixels or something. There's something stupid where you modify the initial sprite, but you get one to begin with, and then you're like dorking with it. But you want to get it at compile time, which means the sprite image file has to be available to the compiler. He has to understand the file system read and all that kind of stuff.
Is it as if it's read from a library or something? Is it a baked thing? It doesn't. He
has all the parts. He just runs it, but he has to have an interpreter somewhere in the world. For me, that would just be I would compile the code and then go and execute. Literally, since I'm jitting the code, I'm compiling it to executable, but I'm willing to execute on the spot. I would just compile this code down to x86 and then execute it.
And this generalizes to multi-stage programming. In principle, you may want to do partial evaluation at any moment of your program build, whether it's the compilation, linking, loading. So there is no reason really to have a language restriction at what stage the compile time evaluation applies to.
Yeah, 100%.
Well, I think there's a argument to have constexpr being the minimum amount of compile time evaluation, but not the maximum.
That's correct.
You know?
Well, you have to you do have to say the user wanted this late. Like I said, my sprite here. If I didn't have constexpr on it, this was not here, then it has the semantics that the file my sprite is checked at runtime, which is after the compiler is long gone, and is different than the my sprite the compiler had at its time. So you can't do this
Yeah.
without
Resources I don't handle that way. It's like,
yeah, where's formatting here where I make this a slash through? There is no formatting here. Fine.
I believe it's Control S.
You think Control S? That's not save file. No, didn't do it.
Oh, maybe it is.
Under italics link, none of these. Normal text. Oh, it's size. Font. I give up. It's not worth it. Okay. Yeah, but we know what is attempted here. This one the user has to specify. Do it now. Do it later. But if you can say do it now, I totally know.
I absolutely abhor the idea of compilation not being sandboxed. I should be able to compile an untrusted program without running inside a VM. The idea of doing file system I/O in a compiler is a horrible idea from my perspective.
Oh, somebody found it. This is a case where if I pull down untrusted code and I'm compiling it and then I don't want it to do at compile time things to my file system, yeah, I can argue the compiler has to be told allow this to do unsandboxed execution. And if I
But if you don't trust the code you're pulling down, it means you can't run the executable.
Say again?
If you don't trust the code to run in the compiler, it means you can't run the executable it produces.
That's true too.
Right, but you could look at the generated assembly or whatever, or run the executable.
You're going to look at
compilation
generated assembly as opposed to look at the source.
Compilation is just the first step of running a program.
Yeah, right.
So
yeah, it's just a stage. There's no reason in principle it has to have any more or less restrictions.
Yes. Or I run my interpreter on it. It's the same thing. My interpreter's going to go read the file system. So sure.
Yeah, I like the idea of distributed builds though. Like if I have a server farm and I want to run builds on 200 machines, you know, I would like to be able to let anyone send code to the server farm and get their binary back without, you know, them having to compile it locally.
Then you have a couple options. One is you tell the compiler that he has to sandbox and he just disallows. And one of them is you tell the compiler he's expecting these other parts to be available somewhere. Another one is you speed up your compiler by quit using LLVM, and then you don't need a 200 server farm.
I'm sure that conversation went well at Mojo.
Yes, it did.
So Cliff wants the meeting to end.
Oh yeah, it's about time.
So the one other question I had in my example where I'm doing the regex compile, because I read the file at runtime and I did the compile at runtime because I don't actually need these. What happens if my regex library is only ever used inside of constexpr? Does that get cleaned up by dead code analysis that says
whoa, somebody wiped something out here?
No, I just moved it. It's in the next one. Next one.
Down?
Down. Just one spot.
I missed.
If I'm doing something like this.
Yes. Oh, this is however the compiler as if works. Like suppose the compiler is only used at compile time on the regex. You're saying it is used on, then doesn't.
Not only can I do this compile at runtime, I can literally remove the regex compiler from my compiled binary.
Well, you wouldn't put it in. Or at least for simple, I'm going to say who goes in the compiled binary is who's going to access it, and no one's accessing it at runtime, so it won't go in.
Okay, but somebody had to compile the regex compiler so that I could call it at compile time.
It had to be available at compile time.
It will be interpreted.
The same problem is that
it will be interpreted.
So you're like jitting the regex compile at compile time and then throwing it away?
If you, well, what I'm doing with it now as a separate compilation, if you ran it as a single one-off from the start compile, that's what would happen. If you ran it as any kind of separate compilation, you'll have a regex.o lying around But when I go build the executable in the end, it won't have the regex in it. But this is
Like,
like,
if I still have one of the calls to regex compile that is reachable by runtime code,
yeah, then you'll
then it
have
needs to be in the binary.
it'll
But
be
if
in
I
the binary,
don't, then
right?
I don't.
There is this linky-like step I do before I spit out an ELF file, where I just gather up all the reachable things. If you're reachable, you're reached, and if you're not, you're not. So somewhere in the world, I had the regex at some point being read, at some point being reachable, at some point being passed a standard fixed set of bits. And somebody said force constexpr, so he inlined furiously and folded all the bits and did the math, computed your value. Okay. Now he's
Yeah.
done, and that one compile has completely inlined to some value. And
So my
no
next
reference
version is
history.
what happens when I move the constexpr.
Well, that one says I read a pile of bits, and now I have an array of bytes that would show up in the
Right.
constant pool as an array of bytes just slapped into the constant pool. And then
But
I make a
depending on
runtime
how
call.
smart my constant propagation is,
Yeah. Yeah,
it might
this is
say, hey, I read this file into a constant. Oh, regex.compile is a thing that takes a constant and returns a constant. I can constant propagate through it.
yeah,
Let me run this potentially very expensive regex.compile at compile time
yeah,
because someone promised me that it takes a constant and returns a constant.
right.
Yes.
This gets into
And now
quality.
it's again dead and can again be removed from the binary?
This is a quality of implementation of the optimizer. Does the optimizer now see the first one says you must inline. No choices in the optimizer, he has to do the job. Second one says I get to pick whether I'm going to fold it now or do it at runtime. So suppose regex constexpr is only under some very rare condition, like if you ran out of disk space and you need to put out a pretty message. And no one ever runs out of disk space typically, so you never see the pretty message. So it's all just dead at runtime. So why am I building it at compile time? Or it happens a billion times a second, and I badly want it to be built, and the optimizer build it. This is optimizer's choice. Do it now, do it later. And I'll probably go to the standard heuristics I do for I'm passing a bunch of constant arguments to a giant ass function call. Maybe it's worth inlining and folding. Maybe it's not. Some heuristic kicks in.
Yeah, my guess would be most constant propagation would not take the second one and realize that it doesn't need regex compile in the binary.
Um,
Well, yeah, look,
well,
I'm
I happily inline a fair amount in C2 if I have constant arguments. It's not the end of the world. It's not infinite for sure. Typically, I stop at loops, not at inline function call boundaries. If I have
Right.
a
It is a
loop,
function call to a different module.
if I have it available to me, oh, in a different module? No, no, no,
But
no,
it is
no,
also a
no,
thing that takes
totally.
a constant and returns a constant and potentially promised you no side effects, assuming there's some kind of metadata where it can promise you no side effects.
Yeah, the compiler told me that already. Okay, so for C2 and simple both, I have the other side of things. I have the module for the regex. C2, it's been loaded in memory and initialized, and I did things with it, and I got whatever I got out of the C2 on it. For simple, I'm going to say I have this function call to this other module who I have the complete IR state and type system product when it got compiled. And from there, I can make a judgment call. It's a pure function taking a pure constant, going to produce a pure result. And I can see just how fucking big it is and decide I'm going to inline it now or not. So yeah, this can be done using what I'm doing with simple. Now, how much of this is actually implemented? Well, I don't have constexpr for sure.
It's
Um,
my opinion that constexpr in C is going to, in 20 and 30 years, going to be viewed exactly the same as the inline keyword. People are going to put it in, and the compilers are just going to ignore it
yeah, could
because
be.
the compilers are smarter than the people.
And then there's the register keyword before that. We've been down this path before. You think
Right. I
velocity
would
going in
argue
circles?
that the programmer best practice should be that I should do this second line, not the first one. And the only thing I should put the constexpr tag on is the read file because I really want that read file to
Yeah,
happen at
that
build
one's
time. That file doesn't
semantically.
exist at
Yeah,
runtime.
yeah. But you said best practice. That's under some current state of the world or some hypothetical future state. If I'm a game writer and I need to have my sprite loaded and I'm going to hack and fuck, I'm going to play with my sprites. I absolutely want them, and I absolutely want them through a sprite editor. I absolutely run them through whatever tweening animation is going to happen, all done at compile time. Read that sprite, do the tweening things, all at compile time. I'm going to force it, and I get it. That makes sense. So I'm happy to
And
fall down
games
the
do
rat hole
things,
Ben proposes.
here's my 3D object. But
Yeah.
what I need is the profile picture of the character in the 3D object. Great. I'm going to load it at compile time, and I'm going to take one view from it. I'm going to make a flat image.
Yep. No, submarine battle simulator, a top 10 game I wrote in the late 70s.
Although the trick with some of those is people will often simply have a separate C++ binary that is the asset
Yeah, right.
builder.
Yeah. I took
And they're not using something like constexpr for that. They just have an entirely separate step of their build that they run much less often than they run the real build.
I took profiles of all kinds of ships and rotated them through a series of angles and produced a bunch of bits in memory that did profile outlines of ships at sea seen a long ways off at different squunchiness according to their
But did you
profile.
do that with some kind of compile time execution that was in your language, or you just had a build step that built its own binary and did its own thing, and that was just a separate program?
Right, did a build step for that. But I would have demanded having this. I would have preferred to have this, but it was a separate build step. Yeah.
So that's sort of my question. At the very least, I want the suck in file, stick it in a byte array.
Yeah. Yeah.
But it might make sense to have everything else be just its own separate program that then puts files on the machine and you just suck in files.
All right. I'm going to call it because Ben says it's right. It's after 10, 12.
It is after 12.
And
Oh
also,
no, that was a smart ass comment about your attack.
Oh,
your comment about C++. You like lobbing the grenade and then going, okay, it's time to exit.
Yes.
That's all that was.
It's fair. No, sometimes at noon I need to go, and sometimes I don't. Today I don't actually need to go. That being said,
Yeah.
I think the comment I love the constant expert notion, and I think the comment that it'll be stale bread in 20 years is probably spot on.
So
But I do wonder if it should just be compile time call rather than constexpr.
Oh yeah, whatever the keyword is. I don't want to bite shit on
And
keywords.
say, I don't actually care whether this thing returns a constant or not. What I want to do is make this tag that says this function call right here happens at compile time, and whatever it returns, it returns. Like, fine.
Oh, I see. As opposed
Why
to,
make it return a constant or a value?
well, it's a value.
I mean, obviously it's
Yeah,
problematic
right.
if it returns a like file handle to a file on the file system that's not going to exist at runtime, but
Right. You're saying do this thing at compile time, which is totally legit. It's fine. And the end result isn't necessarily a constant. That's why I moved the constant expr out from the left-hand side of sprite to the right-hand side because I want to be able to hack my sprite. I don't get a constant back, but I get a compile time value back that I then mutate.
well, what do you think? I did have a localization topic. I don't know if you want to scroll down a bit and look at it.
Same as we do every week. Grab your localization topic and bring it next week. We had a lot of these things left over from last week that we didn't start up again, but we could have. I'm okay. Bring it next week. Okay, so I'm going to call it.
for your
fun.
whole description of your modules
most.
design, do you have code for that yet, or this was still modules design?
Which one?
The thing we started with at the very beginning of the meeting was here's how I want to design modules for simple.
Much of it is in progress. So we're way down here at the bottom. All this. Okay, so I believe this works. I know big chunks of this work directly. This is mostly working, and I'm beating out bugs on it, which means that this should work and isn't been tested because I don't have this working, but it's close. And I don't see why this shouldn't work. I do have a case where I look up pet in the build line. We'll find it over here. I haven't tested pet. I look up sys in the build line. I find my sys for my sys.io.print. So that works. So the remote cross-file module build thing goes. The .os that are nested here is not working. So as a separate file, as a common file works, as a separate file does not, but that's one of the things I'm working on. This one is not, and I'm currently mid progress of doing this guy. So at least 50% is going. I was kind of enough along that I wanted to say, am I doing something stupid? And no one said you're doing something stupid. We argued out why it would or would not work or whatever, but no one said, this is just dumb, go do that. Which happened last week, and I was like, oh yeah, I could do something better here. Where did I do last week? I said this, just fucking put, don't try to figure out who's in and out of the init versus the clinit. Like Java, you have the interleaving of the two, and you have to static or not, and they're all interleaved, and you have to tease them apart. C++, same thing. You have to tease them apart. Here, somebody said, don't bother, just put a struct pet, and anything inside of here, that's in your instance, and anything outside, that's in your clinit. Okay, that makes a lot of sense to me.
Yeah, the fact that it made the word static go away in a whole bunch of places.
It makes static go away and makes reading the code a lot easier because you're just going to find struct pet some usable place. That's it. This is
and it's fewer concepts to teach people the language model.
There you go. And then I went through how do I do nesting and how do I get, substructure and file system hierarchy, and that all adds complication, but it's all straightforward at that point. Okay. So yeah, like this shit is basically working. Okay, done. Stop share. Walk away. Run in fear and terror. Yeah, it's good fun, and I like
Happy
how
Halloween all. Eat some candy.
Here. Sorry, go ahead.
I said Happy Halloween all. Eat some candy.
Yeah, it's never a problem for me eating candy, or maybe it is a problem that I'm always eating candy or something. Why wait on Halloween to eat candy?
You can eat candy more than once a year?
Oh my God, I eat candy more than once a day. What are you talking about? All right, next week.
Bye.
Bye-bye.